Stuff That Talks to the Interwebs is my workshop series about IoT, and originally it was with an Arduino and a Wi-Fi shield, but now I do it with Raspberry Pis and Wi-Fi. Obviously, a little Raspberry Pi is a great prototyping platform for Internet of Things. I call it Stuff That Talks to the Interwebs. But this is where I talk about my work, fireworks. So I'm still talking about fireworks. Pixel Pyro is the biggest project I've ever done. It's massive, huge screen. How wide is it? It's like 20 meters wide. It's like crazy wide. And I project computer-generated fireworks onto this screen, and each one is triggered by humans that you can see there. They're touching these orbs of light, and when you wave your hand in front of it, it makes fireworks. Who's seen it? It was in Brighton a couple of times. Yeah, half of you have seen it. Brilliant. I do it with lasers now. Lasers are a recurring theme in my work, just lasers all the time. But Pixel Pyro is primarily a software project. There's a bit of hardware, like you can see these infrared lights behind the screen. They're completely invisible to your eyes, but my infrared cameras can see it. I feel I've got some footage here, which is pretty cool. So this is what my infrared cameras see, and that's how the motion detection works. But apart from that, there isn't really much hardware. A couple of years ago, I made a project called Laser Light Synth, and it was the opening to the Brighton Digital Festival, and this was probably the most sophisticated electronics project I've done. So essentially, in the last few years, I've just been doing less software and more hardware. Well, I suppose even when you're doing stuff with electronics, it's still very much like programming as well, right? There's always a very closely knit programming side to all of these electronics things. I don't know why we haven't got sound, but that's not important. Lunar Trails is another really heavy electronics project. I could talk about this for ages. In fact, I might just get my phone out so I can keep an eye on the time, because I have literally no idea how long I'm going to talk today. So, you know, if you want to just shout questions or whatever, please do, because it's totally loose. Like, this talk is completely loose. I should have said that at the beginning. But that's fine, you'll figure it out yourself before too long. So this project is based around my obsession with the 1979 arcade game Lunar Lander. This is actually my own Lunar Lander cabinet. I bought it on eBay. It's in LA. I can't get it. There it is. It's just sat in my friend's office. It's in his canteen. All his staff play it, but apparently they still enjoy it. So that's fine. I'm never going to get it. It's fine. This is what it looks like. It's a beautiful vector rendered display, and I made a perfect recreation of that in JavaScript. You can play it yourself at moonlander.sebly. I don't know. Do you want to? No, I'm talking now. Do it later. We'll do it in the break, and then we can have a look. And you can play this game and try and land the ship. And I thought, wouldn't it be good to spy on everyone playing the game and leave little trails when they're moving around? And it made art, so I accidentally did an art. And then I thought, wouldn't it be even better to make a big physical version of this? So I bought an arcade cabinet, flat pack, just like IKEA, and this was like the first time I'd really done much of this sort of building stuff, and I was so excited. Look, I did metal work, there was sparks and everything. I learned about servo motors, because not only did I have to build the arcade machine, I also wanted to build this massive drawing machine. So with the help of an engineer friend, I built this hanging plotter, all based on Arduino. Oh, now the sound comes. Okay, good. Out of my little crappy speakers. But you can see the hanging plotter here. It's got two motors, the top two corners, and it winds in and out wires, and it moves the hanging pen holder to draw any shape that you want, really. It's quite a sophisticated system. So as you play the game, the arcade game, the drawing machine actually plots your path that you take in the game in real life, and you can see it running there. But I haven't got time to dwell on this. I've got to move on to Laser Arcade. So I told you about that I like lasers. And this was right after I'd just learnt to do lasers with Pixel Pyros, and I thought everything has to have lasers. And so I recreated an old classic shooting gallery, but with laser projected targets and Nerf gun darts, right? So you actually would fire a real Nerf gun bullets at laser projected targets. And this was a crazy project because it used microphones to pick up the sound of where the bullet hit the wall. And there were 6 microphones, and it measured the tiny differences in the amount of time it took to reach each one. You can see there the gap there between it, and some really complex maths, which I could talk about for ages, but I won't. I've got no time at all. I've got so much to get through. I'm doing a new version of Laser Arcade. It's going to be in. I'm going to be doing it in the Digital Festival. Definitely at Bring Your Own Beamer, the projection event at the Corn Exchange. And I might also be doing the opening event of the Digital Festival. I'm not sure yet. But instead of using Nerf gun darts, because frankly I'm sick of picking up Nerf gun dart bullets, I've got myself a couple of these Nintendo Zappers from the NES. Anyone play Duck Hunt? Yeah, you know it. Really cool. I could talk about these for ages, but I won't. But all you need to know is that I ripped the insides out of one of them and made my own custom circuit board. You can see it there. That's the design, and then it was all milled out on a CNC machine. I'm redesigning that at the moment, but essentially I want it to be a real laser gun with real lasers in it. But the thing with lasers is you can't really see the laser beam unless there's loads of smoke. So I could just fill the room with smoke, but I thought that's a bit boring. So instead, well, first of all, I covered it in NeoPixels, and you can see the laser beam coming out there. But you wouldn't be able to see that laser beam at all unless there was a bit of smoke in the room. I just happened to make some smoke in the room, but I thought, wouldn't it be better if the smoke's coming out of the gun? So I basically spent altogether too much time trying to figure out how to fit an e-cigarette inside the gun, obviously blowing out nicotine-free vaping fluid. Obviously, you don't want to be giving everyone a little nicotine buzz while they're doing it. So, but it's not enough to have an e-cigarette in there, because if you just power up an e-cigarette, like the vape smoke doesn't come out. You have to physically push it out with an air pump, right? So I managed to find not only a really tiny e-cigarette, but also a tiny air pump as well. That's blowing through the e-cigarette, but that's not enough to really drive out the smoke. It just sort of blows it out of the e-cigarette, and it just sort of lingers there. So I also had to find a tiny, teeny little fan, which is also, and then I had to fit it all inside this gun, which is quite small. Anyway, this is a work in progress. This was this morning, so that's kind of where I'm at. But you can see with the smoke, the laser looks really cool, doesn't it? And I'm sort of finally thinking, because up to this point, this is never going to work. I've bought so many e-cigarettes and fans and pumps, and it's never going to work. And I'm just wasting all my time and money. And then this morning I was like, oh yeah, that could work. So that kind of defines my process. Anyway, I can relax now because we're back to the subject of my talk. I just get so paranoid. Everyone's like, oh, stop talking about your projects. Just get to the Raspberry Pi stuff. Okay. Raspberry Pi. So yeah, we talked a little bit about it. I mean, it's such a wonderful project. And it's nice that there's a product that is a massive success. What have they sold? Like, I think it's 8 million now. They've sold 8 million Raspberry Pis. That's the best-selling British computer ever, which is fantastic. But most brilliantly, you know, the thing that I really love is it's not some corporation making tons of money out of it. You know, it's a charitable foundation. They exist solely to get more computers into the hands of kids to learn to code. You know, that is great. Almost accidentally, they've started this whole other community. It's at multiple communities, you know, artists, engineers, installation people, like museum people or whatever, hobbyists, makers, you know, all of these different people have started to use Raspberry Pis, or musicians. You know, there's any number of things that you can do with it. And although I've been working with them for quite a while, I've pretty much only been doing electronics, but you can do loads of other things with them. Obviously, you know, I've sort of covered them a little bit. So I love Raspberry Pi, but I always, up till recently, preferred Arduino for small electronics projects. I guess Arduinos, they're quite expensive, but actually the parts are very cheap, and you can get clones as well. You can get Arduino clones very, very cheaply, and actually, because it's all open source hardware, you can sort of build your own Arduino even cheaper, right? So if you're designing a product for market, you can basically recreate Arduino and make your own custom version of it with all your connectors and your components that you need for your product. And that you know, that's great. And with Raspberry Pi, you know, you do get a full Linux computer. There's a certain amount of overhead with that, whereas you wouldn't necessarily want like a smart light or something to have to boot up before before it works, right? And so Arduino is really good for those sort of things. But Arduino isn't necessarily very good at internet, right? It's okay at it, but it's not very good at parsing text. You need extra hardware if you want to use secure connections and stuff like that. So it's getting better all the time. But obviously, if you work with Raspberry Pi, it's just got glossed over all of those problems like brilliantly. I mean, obviously at the cost of having a Linux operating system, but that's fine, you know, because you get so many other benefits. Plus, of course, you can also program it in JavaScript, which, if you know it already, is kind of cool. So yeah, the Pi Zero, I mean, this is where things got really real, right? Because the Raspberry Pi, what, was 20 quid or something like this? Like, this is like £3.50. You know, it's like, it's so ridiculous. So even once you've bought the SD card and the power supply and all the cable, the Wi-Fi dongle, it's still probably cheaper than an Arduino, right? So without any Wi-Fi. So this is really revolutionary. Of course, you can't get one for love nor money, right? But no, stock's getting a bit easier now. But yeah, unbelievable. And you sort of think, how on earth have they made a whole computer that cheap? I mean, and still make a profit? Well, the answer is I don't think they are making a profit. They've done it literally at cost, again, just to get more computers in kids' hands. And they've brought out the Raspberry Pi 3 now. I've got one over there. It's like the same sort of form factor as this, but it's also got Wi-Fi and Bluetooth built in. And they're like 25, 28 quid, something like that. So they're making loads of money on Raspberry Pi 2s and 3s. And so they don't necessarily have to worry so much about making money on these. Again, isn't it wonderful that it's a charitable foundation that has totally different motivations than a corporation? I find that really refreshing. So yeah, what have we got here? Well, I mean, I suppose I don't really, all the usual computer stuff, right? It's got this port there is to plug the power supply in. Here's a USB port. Obviously, it's tiny, right? So if you want to plug in actual USB stuff, you need an adapter. It's got a mini HDMI. So if you want to plug it into a monitor, you need and it does. You could either get a mini HDMI cable or you can get an adapter. You know, they've obviously made compromises to make it so small. SD card slot there. Oh, and the new ones. This is an old one, but the new one, I don't know if you can see along the top. There's a little white connector at the top. That's for a camera. So the Raspberry Pi has a Pi camera, and all the other Raspberry Pis have those Pi camera slots there. But this is a sort of slightly smaller one, but you can get a different cable and plug in a camera into this. So brilliant, the new model Zero. But I don't really care about any of that stuff. I don't really need the USB particularly or HDMI. I'm not plugging in a keyboard. I'm not plugging in a mouse. All I care about is this, the GPIO header. And it's two rows of pins. I think there's 40 of them. And these are, well, they're GPIO pins, right? That just stands for general purpose input output, right? It sounds complicated, but all it is something that you can connect bits of electronics to. And I don't know about you, but I can't remember the last time a computer had something like this. Since maybe the BBC Micro, right? At school, you could plug in robots and motors and electronics into the BBC Micro. And since then, it hasn't been that easy to do that, right? So I think it's great. And they sort of, I don't even think that it's that important to Raspberry Pi. I think they probably wanted to do it because they wanted to be like the BBC Micro. But I think most of the educational resources aren't necessarily around the electronics, but of course it's a wonderful thing to be able to program something and have something physical happen. I think that's a huge part of the appeal of the Raspberry Pi. You can see the GPIOs there. I mean, you don't have to worry too much about them, but I guess I could just give you a very quick lesson in electronics. In fact, I'm going to have to do that. But yeah, before I do that, most of these pins, some of them have got special functions, but most of them can either be set to an input or an output. Who's ever done any Arduino before? A couple of you, half of you, I guess. All right, so those of you who have done Arduino, you know you can set a pin as an input or an output. If it's an output, you can attach an LED or a motor or something to it, and you can either put electricity into that thing or not put electricity through it, right? And you can do that with code, yeah? And you can also have it as an input, so you could have either electricity going into it or no electricity going into it, and you can read the state of that pin in code. So that way you can have switches and buttons and stuff like that. So you've got inputs and outputs. Oh, do I have time to explain electronics? Yeah, why not? Right, so you'd have the battery at the bottom. That's, which way around is it? I don't even know. It doesn't matter. That's the sort of battery symbol. I can never colour those in. And you'd have, like, in those days, well, in my day, oh my God, I'm old. You would have actual filament bulb, right? So you've got, like, plus and minus. I think that's the right label. And so this isn't really what happens. Like, it's crazy what actually happens with electronics and electricity. But we all believe this lie, which serves our purposes and is a perfectly adequate model for 99.9% of all the electronics you want to do. And that model is that electricity comes out of the plus side, goes round the circuit, through this, whatever it is, makes it light up, and then goes into the minus side. So you can think of it like a plumbing system. You can think of it like water taps, right? So this could be your mains, and I don't know, what would that be? I don't know, a mill or something that the water's pumping around. This is a crap analogy. And it goes out into the drain. Right, so that's a basic circuit, but what's that got to do with Arduino? Well, hang on, what am I teaching? Raspberry Pi. Same stuff, right? It's all GPIOs. So all of these input and output pins, they either put out or can read in up to 3.3 volts. If you put 5 volts into it, you'll damage your Raspberry Pi, potentially, which is really dangerous, right? Because you see there's 2 5-volt power pins up there, right? So if you just plug one of those into any one of the other pins, you've broken your Raspberry Pi, right? So in that way, Raspberry Pis are a little bit fragile. Arduinos generally just run on 5 volts throughout, so it's much safer. Just thought I'd probably better give you that warning. So how do you use GPIO pins? Well, what you can do is on this side, instead of plus, you can actually plug in a wire into a pin. I'm just going to call it P, I don't know, any one of those pins. Take a wire out of that, put it into an LED, which is a light emitting diode. Does everyone know about those? Some of you probably don't, but that's okay. And then that goes to ground, right? So what I've got is an Arduino, a Raspberry Pi pin going out there into an LED and to ground. Now with code, I can set this pin to be an output. And also with code, I can either set this to put out 3.3 volts or I can set it to put out nothing. So obviously if it puts out 3.3 volts, then the LED lights up. And if I don't put if I turn it off, then the LED turns off. And I can do that entirely with code. In this case, I can do it with JavaScript. Oh, what else do I have to say about that? Okay, so what you're actually doing with the pin, rather than sort of turning it on and off, you're actually saying you're putting either voltage in there or you're putting it to ground, right? So turning it off is the same as putting it to ground. It means that it's ground on both sides and there's no electricity going anywhere. There's nothing happening. So that's sometimes known as, you could consider it to be on or off, but often it's referred to as high and low. Right, so if it's high, then you've got voltage coming out of it. If it's low, then it's gone to ground. I designed these baseboards with my logo on. They're very cool. I wonder if there's a picture there. There you go. You can see it. You can kind of see it there. And the Raspberry Pi sits on one side on these little spaces. I've also got a little key of like a little label for all the pins. And on the right hand side, we've got this thing called a breadboard. Who's ever used a breadboard before? Yeah, so for those of you who don't know, it's a way to make circuits without having to do any soldering. So these holes are connected in a certain way. So if you plug one wire into one end of that row and another wire into the other end of the row, then those two things are connected. Right, so it's a very easy way to set up just prototypes, electronic circuits. So with the kit, I just give you a ton of like LEDs. Those are the LEDs there, loads of other components, resistors and stuff. There's a button. And that's basically how we build these prototype circuits. So in this case, with code, I'm turning those LEDs on and off when I'm reading the signal that's coming from that button into another pin. So I've got one pin for the button that's either going high or low when it's pressed, and each one of those LEDs is connected to another pin. And with code, I'm telling them to switch on and off. You'll notice that they're fading up and down. That's a whole other level of conversation. Those kind of inputs and outputs from a single pin are probably the most simplest form of electronics, and you can do some pretty cool stuff with that. But there are a wonderful array of other types of components which you can also interface with. So you see here, we've got several. I mean, this is all part of the kit as well. I don't mean to sound like an advert for my workshop, but I can't help it. I'm sorry. It's how most of the stuff I do doesn't really earn any money. So the workshops are the one thing that subsidizes all my laser fun. So, so you can see here there's a few different kind of components. There's an 8x8 LED matrix. I'll fire one of those up later. And a 7-segment display. You see there's 8 characters, and each character is 7 segments. And so both of those things are controlled by the same chip. So there's actually a chip on that circuit board underneath the display. And so rather than interfacing with all of those 64 pixels directly from my Raspberry Pi, I've got to stop calling it an Arduino. That's just embarrassing. I haven't even been using, I suppose I have been using an Arduino this week. That's my excuse. So there's a chip on that board, on that module, on that LED module. So rather than controlling every single LED individually, I can just interface with that chip through a couple of wires, 3 wires in this case, and I can send data down those wires to tell the chip that's managing that display what to do. So rather than using up all your pins on all of those LEDs, there's ways to interface with multiple LEDs with just using a few connections. And there's a few different data protocols that you'll start to become familiar with too. This one here is an OLED display, so that's really cool. Again, uses a simple data protocol to send data back and forth. They're beautiful, those OLEDs. Again, I've got one here you can have a look at later. 128 by 64 pixels, I think, and they're less than an inch wide, so they're really high resolution and really fun. Yeah, that's probably all about that. But then we come to NeoPixels, which are my favorite thing ever. Do you remember the laser light synths from 20 minutes ago? The laser light synths are completely made out of NeoPixels. I think there's about 800 in a single laser light synth. But this is a NeoPixel ring. You can buy those in quarters from Adafruit or any of the UK suppliers. They're really cool. So these are massively bright LEDs. But again, they're just really clever. Like if you have a look at one of these little LEDs, see that little black dot in there? That is a chip, right? So there's not only a chip in there, but there's also 3 LEDs. There's red, green, and blue. So each one of these LEDs can be any color that you want, which is cool. But not only that, they are strung together. They're daisy-chained together. So there's one line of data that goes into the first pixel, and it goes out of the first pixel and into the second pixel. Just one line of data, and we're sending pulses of data through the first one and onto the second one. So you can control, maybe 100 NeoPixels just from one wire. Right, that's kind of insane.
Do they sort of have a state in them? So if you're sending the same data, they can say, oh, okay, I'm responding to data X, and it's sort of listening for X, or is it?
Kind of, right? So you've got to decide how many NeoPixels you've got first. Oh, NeoPixel isn't their real name, by the way. That is what Adafruit decided to call them, and everyone else has picked up on it. Thank goodness for that. I was going to swear them. I've got to watch my language today. Sorry, Jay. Thank fun for that, because their real name is WS2812B. Well, that's the name of the driver chip anyway. So yeah, anyway, what was I saying? Yeah, so I'm going to have to really get into this now. So you send a bunch of data down the data line, one block of data for every pixel that you've got, yeah? So the first pixel just gets the first chunk of that data, and it sets itself to that color. But then when it sends the data to the next pixel, it just takes that bit away, right? So the next pixel is missing the first bit, but it gets the second onwards, and then it deals with that bit of data, and then it takes that one away and sends it along. So that's how they work. They're really clever. Obviously, that's not great. They're a little bit fragile. That data line is a bit fragile. You have to be a bit careful. Plus, also, they draw tons of current, right? They draw 60 milliamps each, which isn't very much, really, except when you've got 800 of them, that's like 40 amps. And 40 amps, when you're using 40 amps, you need wire that's maybe 5 mils in diameter, right? So it's very difficult to power them. Anyway, sorry. I could talk about NeoPixels. I've got some here. You can have a look at them later. They're not on at the moment. Save that for later. I don't want to ruin it, anything.
800 of them from a single wire.
I mean, I don't believe that there's any limit, right? But obviously, the longer your strip is, the longer it takes to send all the data down, right? So your frame rate will go down significantly. Plus, also the data does deteriorate as it goes through the strip, as well as the resistance increases through the strip. So, I mean, really, I probably wouldn't put. What am I doing? I'm just thinking. I'm you know, Rebo, the company Rebo. I'm doing a hack day with them, and they want to put NeoPixels all around their windows. And I think we're talking about what is it? It's like 6 meters of 74 per meter, so it's about 600. So we're going to try putting 600 on a single line. We'll see how that works. But in theory, it's possible. You might just get a few issues with data, and it might slow your frame rate down. With Laser Light Synth, I split it up into 5 tracks. So there's actually, I think there's 9 rows of pixels. So there's like 4 sets of 2 and 1 set of 1. So I think there's never more than, I'm just trying to think, there's probably like, it's probably about 100 per line, something like that. 80, 100 per line, so no more than maybe 160, I think, in that project. And so yeah, the Teensy is really good. Some things are better at controlling NeoPixels than other things, but because it's using DMA, it doesn't hold up the, it doesn't block the code, right? Obviously, if I was doing this with a Raspberry Pi, especially in JavaScript, it can get very slow because it's all blocking code. Although, we'll come to this later, but usually the libraries that you use in Node.js for controlling the electronics are they're actually wrapped C libraries. They're wrapped C code, which is its own special set of problems, but at least it's optimized. Anyway, I'm going to come back to cool components later. First of all, I have to talk a bit about some of the challenges. I don't know if it's changing or it's, some of the challenges with setting up a Raspberry Pi, not only with Node.js, but specifically with Node.js for doing hardware stuff. Because you can see I'm running these computers headless. In other words, I haven't got any monitors, there's no keyboards, no mouse, it's a headless Linux computer. So your first challenge is, how do you do anything with it? So you get an SD card, and you can write the Raspbian Linux disk image to it. So Raspberry Pi maintain a Linux distribution, and you can just literally download a disk image, write it onto the SD card, stick it in your Raspberry Pi, and it will boot up. But how do you then connect to that if you've got no keyboard? Well, with one of the older Raspberry Pis, it was relatively easy because they all have Ethernet on. So you just plug in an Ethernet cable and then you'll see it on your network. And then you can connect to it through SSH. So if any of you are new to Linux or a server admin, I mean, this is a way basically to, over the network, access your computer or your Raspberry Pi through a command line interface. Right, so it's as though you're typing in terminal on your computer, but it's going over the network to another computer. So as long as you can see that Raspberry Pi on the network, then you can SSH into it because it's turned on by default on the disk image. So that's cool. If you haven't got Ethernet, which we don't on a Raspberry Pi Zero, then it's a bit more challenging. Well, there's several, I mean, there's so many options, right? You can get a micro USB to Ethernet adapter. That's one easy way of doing it. You can also get a serial interface. I've got one here. A serial interface, and plug it into some of the pins on there, and then you can access it through USB. So you can connect over USB and through a serial port to the Raspberry Pi. And again, you can access a command line on the Raspberry Pi over the serial ports. Or you can, someone's figured out a clever way of just plugging in a USB cable between this and your computer and connecting through it through serial that way. Once you've connected to your Raspberry Pi once, then you can set up the Wi-Fi on the Raspberry Pi, and so then you just plug in a Wi-Fi dongle. You can see I've got some here, some pretty small ones, and you can see I've just got a little adapter there to make it go from normal to micro USB. Once it's on the Wi-Fi, then you never have to worry about it ever again, right? Because you can just SSH over the Wi-Fi. Any questions? No, so that's basically, once you're in, you can command line, you can do the updates and everything. Yeah, it's obviously if you're new to Linux, that's pretty scary. But I tell you what, I've got this really cool resource on the internet, which is like teaching you command line Linux in a sort of interactive web page. It's really fun. So if you're new to Linux, I should probably get some links together. But if I forget, hit me on Twitter and I'll send you a link. But that's really helpful. But it is, I mean, I've been doing Linux on and off for a long time. I've never really learnt. But just a few years ago, I started doing server admin for my web server, and I was terrible at it for years and years. I'm still quite terrible at it, but I guess just doing it more and more, you start to become a bit familiar around it, and I'm still a little bit sort of lost in the dark. I suppose any of you doing Node.js without too much sysadmin experience knows what I'm saying, right? But it does get a bit easier with time, and I think that tutorial I mentioned does really help. Okay, Node.js on a Raspberry Pi. How do you install it? Well, there's a package manager for Linux, the default one, which is apt-get, right? So you can install Node.js just the Linuxy way, but don't do that, right? Because the Node.js, well, you can do that, but it's like 10.29 or something. It's not a particularly new version of Node. Who's done Node.js before? Most of you, not all of you. There's a lot of libraries on the internet for working with electronics on the Raspberry Pi in Node.js, but they tend to be someone that's just got a bit of hardware working well enough for them and published it, and they're not really thought too much about it from then on. So I've dug around a bit and found some that are good, some that are terrible, but some of them, if not most of them, don't work on all versions of Node.js because they often wrap C libraries or C++ libraries or C++ code. And every time a new version of Node came out, there was a new way to wrap C libraries, right? A new way to write those C code to make it work with your new version of Node. Now, at some point, someone decided this is a problem, and so they invented a new way to wrap C libraries with this sort of, I don't even know what it is, this sort of system called NaN, right? N-A-N. What does it stand for? I've forgotten. I always forget. NaN is like the worst name ever for anything, right? Because it's not a number or whatever, but it's NaN, native abstraction something, I think. So if you write a C library using this magic system, then it works on all versions of Node. But of course, most of the libraries haven't done that, so it's frustrating. But I find if I'm working with 0.12 point something, usually works, or the common ones work, because I think a lot of people working on Raspberry Pi haven't updated Node for a while. But that's one of the real frustrating things, and I've slowly been figuring out how to update C libraries to work with NaN. I'm reasonably experienced and comfortable with C++, but it's still massive pain. Anyway, enough talking. We've gone on quite a bit, haven't we? So should you want a quick demo? A quick demo or a quick break and then more demos? What do you want? Okay, right, so let's just increase the size of this. So you can see I'm there on my terminal, and I'm currently SSH'd into this Raspberry Pi. Yeah, so you can see, I can do all the usual things. Have a look at the file system. This is the file. This is all the preset examples from my workshop. I'm just going to bring that up a bit. Is that helpful? Let's first of all just make. Well, what have I got? Let's just blink an LED, right? So anyone working with electronics will know that blinking an LED is the hello world of electronics, right? So here we are, using GPIO on-off, right? So in this case, I'm using a Node module called on-off, and that gives you input and output access to the pins. So I'm setting one of these GPIO pins, number 21, to be an output. Then I'm just doing this old-fashioned set interval, which you shouldn't really do. This is like this example is specifically to show you how you do Arduino style coding, right? Which always has an update loop, which isn't necessarily the right way, but it's fine. And then what I'm doing is writing to that LED 1 minus whatever the current value is. So that's basically going from 0 to 1. And that's really all the code there is, except some nice cleanup stuff. So then I can just run that by typing node, and hopefully, I don't know if the pins are set up right on that. We should have a blinking light, right? Yeah. Yeah, go on. There is a button on that, isn't there? It's really technical, and you don't necessarily need to know this right away, but on-off accesses the Linux drivers for the GPIO, which is obviously everything in Linux is a file system, right? So that's just doing file access. But this GPIO is doing it in hardware, and because of that, it can do fading. You see that fading up and down. Let's just get to the good one. Come on, Wes.
At the back, can you go see the fading? Okay. Yeah.
Yeah. Yeah. Just right. So now I've basically got fading on multiple LEDs in a chaser. Yeah.
Wow.
So that's the sort of thing you can do, and we can take a closer look at some of that code. A 7-segment display has a chip on it, running it, driving it. It's the wrong way. No, it's too bright. And I actually converted the Arduino library into Node.js for running this chip. So now you can do fun stuff like just put in a counter. And of course, the wonderful thing about JavaScript is that things like parsing strings find data for all the letters in the alphabet, which is actually impossible with 7 segments, but you can see there.
Oh, sorry.
I've done a reasonable job. You can still sort of read it, which is quite amusing. But of course, we are connected to the internet, so you can do stuff like read APIs. Right? So in this example, I haven't tried it for a while, but in theory, this should find out where we are through a GeoIP server, and then it should go to another server that tells us when the next pass of the ISS is going to go over. And so you see that counting down. What's the numbers? Oh, it's going to happen in 53 minutes. Well, that's good, isn't it? It's never been dark when I've run this. When I've run this software, it's never actually been dark. So you can see we're getting some really fun stuff with the internet. But the thing about Node that's really special and makes it a lot easier in some ways than Arduino and C++ is that it's obviously there's a ton of web server libraries, right? It's really easy to make a web server. So what I can do is actually run, do I need sudo? I'm not sure, let's just do it anyway, why not? If in doubt, give it permissions. So in this case, I've actually set up a web server. And if you're on my network is just called SEBS, by the way. So if you want to go to my network, the Wi-Fi is called SEBS. The password is internet with a capital I. And if you manage to get on that, then you should be able to access the web server on my Raspberry Pi. What's it called? rpi-leds, rpi-leds.local. Okay, so this one actually connects to a different WebSocket server somewhere else. So in this case, I go to my server. Geez, I don't know which one. Let's try that. Oh, okay. I don't know if the client's connected to it or not, but can you just push the button on that? Oh, there you go. Did you see what happened?
Oh, yeah.
Right, and so actually when I push this button, stop for a moment, Ali. When I push that, then that light should go on too.
Which light? Oh, yeah.
Yeah? So this is connecting to my WebSocket server that's hosted somewhere else. And I can have a direct connection then between the Raspberry Pi and any browser, right? Which is pretty fun. And vice versa, right? RPi lights. Okay, so this is quite a fun one. So this isn't really part of the workshop, but it's something I've been working on, which is like remote lights. And at home, I've got a bank of NeoPixels that I use for lighting when I do videos and stuff. And I can adjust the white balance. I hope this works. But I think this is on this one here.
Okay. Do you want me
So
to hold it up?
let's just see if it works. Have we got anything? Ah, it's broken, isn't it? Oh, it's gone down. Oh, maybe I have to run it actually. That could be it. This one runs by itself when it starts up, but node. I think it's that one.
It looks like it runs really quite rapidly.
What's that? Okay, so
Just code on the Pi.
right. So here we have an interface. So this is just something I mocked up quickly. I have to finish it off properly. But this is imagine this is like the lights from my photo. Oh, that's. Did someone else turn that on?
Yeah.
All right, I was like, why is that turned on? Imagine that's like a bank of lights, and I use it for my videography. So I can actually adjust the brightness. You can see it gets really bright, and actually I can also adjust the white balance too. So, I mean, if I have it full saturation, I haven't got the full range of hues here, but I can go, from green to orange. And you should, if you've got that on your phone, you should see it updating as well, right? That's the power of WebSockets. Oh, there you go. Someone else is doing it now.
So multiple people can adjust the controls at the same time.
Yep, and it all goes crazy in a really fun way.
Do you know how much this strip costs?
Okay, so that's not a NeoPixel strip. That is something called DotStar, which is slightly different from NeoPixels, but basically the same. And I don't know how much it is. It's if you buy strips from like normal suppliers, it can be quite expensive. But you can, if you're patient, get them on eBay or from China. I think I pay maybe $15 a meter.
Oh, okay. So.
But if you bought it in England, it would probably be £30 a meter,
Oh,
right?
okay.
So it's quite different.
Still, for what's essentially a smart light, that's pretty good.
Yeah, and I've got this other set up there. I wonder if I can connect to that one. Right, maybe that one will work. Right, so I've got another Raspberry Pi set up here, and this one has just got a little strip of NeoPixels. There's 10 on that, so that should be enough to power from an ordinary Raspberry Pi. People are just messing with that now. An ordinary Raspberry Pi, and that little strip comes with my workshop, so it's quite fun. And if you want, we can do some hacking on that in a moment, but let's just run some of the tests. Where are the NeoPixel ones? 4.0. NeoPixel iterate. So Right, it's just actually rebooting that computer. All right, so we'll leave that one for a moment. That's a good opportunity for me to talk about this, which is, so with Raspberry Pis, you get things called hats, right? Have you heard of hats? So essentially they're another little circuit board that just gets pushed on top of the Raspberry Pi and the pins line up. You can see this one is called a unicorn hat. It's made by a wonderful Raspberry Pi supplier and designer of hardware in Sheffield called Pimeroni, and they're brilliant. They make cool cases, and I love their website. So if you want to shop for Raspberry Pi stuff, I'd highly recommend them. They have a lot of Adafruit stuff too. But they've got this. It's called a unicorn hat. It's an 8x8 matrix of NeoPixels, which is pretty fun. Yeah, so we could try running that if you want. Is that one booted up yet? Maybe.
It's booting up.
Oh,
We got one light a different colour now.
what's that on the?
On the
Yeah, so when they just boot up, when NeoPixels start, they're usually blue, but if there's like a bit of noise on the line or something, then one of them might just change a random colour. So that's quite fun. Let's try that one too. Okay, God, the Wi-Fi is really, it's my Wi-Fi. It's just something about this space that's pretty toxic to why there's a lot of radio waves. Okay, CD node, what is it? It was 4.0, and I can put in the number of pixels. Hopefully something might happen.
Ah,
Is it cool?
yeah.
Okay, so you can see how bright though. That's 1 pixel, right? So let's run the other one, which is a rainbow.
Oh.
Yeah. So and that's not even like full brightness, right? I could try putting it to full brightness. And I say try because it will draw loads of current, and it might cause the Pi to
what?
to explode. HSL, so I think I can go to 50, right? Or, yeah. Let's just try it. Okay. I need to see this. Whoa! Right? So that's pretty cool. And like, if you can imagine, this is what I experience. Like, you can't even look at it, can you? That's how cool it is. So, like, you see a bit of retinal burn, right? That was me for 3 months doing laser light synths. Okay, so I also have another fun little device. Where is it? Oh, it's this one. So I really love, you can put those down now. If you want. I really love these little, oh geez, that is bright. These little 8x8 LED modules, actually my favorite. They're so old school and kind of a bit rubbish, but I really love them. They're so beautiful. Let me just plug it in. And it's the same chip as the 7-segment display. So you can just replace the wiring. In fact, you can run the 7-segment display examples on that, but just like random pixels light up. Now, which computer is that? I've got too many computers. Help. What was that one? Oh, that was the LED one, wasn't it? Oh, it's gone. SSH Pi Pi LEDs. That was that one, I think. I don't know, something like that. Sounds plausible. Just do it, man.
Yeah.
That's going to be amazing. Right, so what was I doing?
You'll be the most fabulous cyclist.
3.3. Right, so this little, just make sure it's working.
Yeah.
There you go.
Wow.
Right, so these are really cool. I actually really love this one. And we can have it play Pong by itself as well, I think. Oh, that's pretty cool. Cool. So, I mean, that's a massive whistle-stop tour of all these kind of components. There are obviously lots of sensors as well. You can get light sensors and temperature sensors and distance sensors. I didn't bring any of those today. I was concentrating mostly on outputs. But that's fine. But obviously, we can connect any of those things with the Raspberry Pi to the internet. it's obviously been a really short summary and gloss over. You know, there is full 2 days of workshop of this stuff, and that's still not the full amount. So obviously Node.js and Raspberry Pi obviously you wouldn't have that problem with Python either, but it's just so easy to set up a WebSocket server in Node.js. I mean, it's ridiculously easy. It's like, if you look at some of those code examples, it's just a few lines of code. Obviously it gets more complicated when you have architecture and rooms and, you know, and user accounts and stuff like that. But just to set up a simple connection is really super easy. But this, Hackton Classics, is a new show that I'm putting together for the Digital Festival. And it's essentially like this, but more fun. I'm looking at retro hardware like the Nintendo light guns, like the Casio VL Tone keyboard, some other stuff too. And I'm hacking it and also like doing cool modern things with computers and lasers. And there's going to be loads of audience interactions, motion detection, you know, applause triggered games and stuff like that. So it's going to be a really fun show. So that's on the 28th of September at the Old Market. I don't know how to find out about that really. It's part of the Digital Festival. It might, don't know this for sure, but it might actually be the official closing event for the Digital Festival. Wait and see about that. But yeah, it should be a lot of fun. I'm going to bring a big laser to that. Yeah, so that's some pretty serious stuff. I think that's probably it, but there's all my contacts. Twitter is probably the best way to get hold of me. Yeah, I think that's cool, right?
Yeah.
Excellent, thanks very much.